G'day all, welcome to another tute. Alright, before we get started, I just want to put out a special thank you to Mr. Olsen. Good on you, mate. Yeah, I really appreciate your generosity, and it means a lot to me to know that folks appreciate what I'm doing here. Anyway, good on you. Okay, so let's get started. This is going to be a C# tute, but I'm also going to wrap up the shunting yard tutes that I started with this same line of tutes. So let's have a look where we were. Loading designer, you can continue working. Well, thank you. Okay, so our calculator as it stands is fairly rudimentary, and I think it might be a little bit broken for some people. Some people put in the comments that they were getting a bunch of 3s for the answer, which is obviously not what you want, but don't worry about that too much because we're going to rewrite all of the functionality, and we're going to add bracket buttons as well. So in this particular tute, what we're going to go through is adding a token class. And in the shunting yard tutes, you might remember that we went through the fact that you've got to split an expression, a string expression, into tokens, before you can use the shunting yard algorithm. So we're going to go through that token class today. And a token is just a mathematical symbol. So it could be a number, it could be an operator, a bracket, anything like that. Alrighty, so the first thing to do is add a new class. I'll go new item. What have we got? Code, class, and I'm going to call it token. Like that. Zoom in. Alrighty, so a token is just a mathematical symbol. It can be any number of different things. So what I'm going to do is make an enum called token type, and this is going to be used to record what type of token something is. So the first one I like to put in is just a dummy one, the nothing token type, or a token type that we don't know. And another token type is a number. It could also be an operator. It could be a left brace or a right brace. Okay, so those are the only token types that we're going to work with on this calculator, but the shunting yard algorithm is also able to go through functions. So if we have something like my function, like that, we might have this and this and this as parameters. So my function just here would be another token type, that would be a function call. And also the comma here is another token type, that's an argument separator. But we're not going through that. Anyway, it's just nice to know that this algorithm is much more flexible than what we're actually presenting here. Enum. I'm going to make another enum called Associativity. Associativity. It's a hard word to spell. I think that's right though. This is the associativity of an operator. So an operator can have left or right associativity, and all this means is what order to do the operations if there's two operators with the same precedence. So if we see something like maybe 5 times 9 divided by 4, something like that, we know from primary school that the multiplication and the division operators both have the same precedence. So the associativity is what order these happen in, and if it's left associative, then this particular expression would be read like that, 5 multiplied by 9, then divided by 4. If these operators have right associativity, then it would be read like that. Alrighty, so it's just the order that operations occur, granted that there's more than one operator with the same precedence. That's associativity. Okay, so what do these operators need? First of all, our token type, if a token happens to be a number, we're going to have to record the value of it. So I'll just call that value, double value. I only use doubles, you can use whatever you like. I'm going to use doubles just so our calculator is nice and precise. If it's a number, it's going to have a value. I might put here a comment. If it's a number. If it's an operator. Okay, so the other token type is an operator. If it's an operator, it's going to have a bunch of different values. So first of all, we need something to record what the operator was. I'm just going to use a char, and I'm going to call it symbol. and I'll just set it to space as a default, but that's going to be something like, I mean, the plus operator has that for a symbol, you know, the plus sign. The minus operator has that, and the multiplication operator has that. Yeah, I'm sure you can see the pattern. Anyway, that's just going to be used to record exactly what the operator was so that we can call the correct function and evaluate it properly. Operators also have associativity. I'll just call it assoc, and I might set it to left by default for no particular reason. Operators also have a proceedings. Set that to 0 by default. So the proceedings is the order of operations without any brackets or anything. So the multiplication and division operators have a higher precedence than plus or minus, so they get done first. Yeah, that's the proceedings. Also, there's int parameter count. Set that to 0 as well. So if it's an operator, it also has a parameter count. It won't come up in this tute, but there's a very big difference between something like 9 minus 3. This symbol just here is a binary operator. It takes 2 operands, the 9 and the 3, whereas something like -7 is a unary operator. Why did I put a semicolon there? Yeah, the negative symbol is a unary operator, and there's also binary minus operator. So that's the parameter count. Yeah, 1 or 2 operands. And if you're using function calls, if you've got function calls as a token type, then you know the parameter count can be anything. You could have a function that requires, say, 20 different parameters. Alright, good. So I think that's about it for the different things that these particular token types need. Okay, I might just make a private. That's not a P, bro. Private token. I'm going to make a private constructor called token. Yeah, I might end up changing the visibility there, but I think private's good for the present. And I'm going to go public static token. String to token, string str. Okay, so I'll make a public static method for creating tokens from strings, and what we're going to do in probably the next tute or the next one after that, we're going to type in an expression in here with our calculator buttons, and you know we'll put bracket buttons as well. And then as soon as we hit equals, we're going to split the string and send each of those little split strings into this method. So this method can pass the string, P-A-R-S-E. Have to be careful here between pass and P-A-S-S. Anyway, the string that's passed to us, P-A-S-S, is going to be passed by this method, P-A-R-S-E, and we're going to return the token. So what we need to do is create a new token. Token T equals new that. Whoa. Alrighty, so now we have to read the string and figure out what it means. The first one I like to check, it's completely up to you, but the first one I like to check is if it's a number. So we can tell if it's a number by double.trypass, the trypass method. This returns true or false based on whether or not the string can be passed to a double. T.value. If, and you just can't put a semicolon there. Okay, so if the number can be passed as a double, then we're going to set that to... Sorry, my washing machine's playing with my speakers. We're going to set the token type of T... No. Oh, what am I doing? What am I doing? They don't have a type for all tokens. They don't have a type at the moment. I made the enum, but I never actually made an instance of it. So, yeah, you'll have to add a member variable there called token type. Otherwise, you're not going to be able to remember what token type it was. Okay, so if it can be passed to a double, the token type is a number. Else if str equals one of those, not one of those, one of those. If it equals a left bracket or a left brace, then you've got to spell things right, but token type, no, t.token, oh gosh, if I equals a left brace. Might get rid of those actually, they're not needed. Alright, if it's a left brace, we put it as a left brace. If it's a right brace, we put the token type as a right brace. Else, and this is where things get exciting, drum roll, else switch with a W instead of a Q, and with the letters in the right order. Else switch string, case, one of those, what happens? Okay, so if it's not a number, if it's not a bracket, then it's probably an operator, so we'll use a switch. First of all, token type, no, you've got to put T in. Token type equals operator. T.proceedings. Actually, I might do this in the order that I define them up here. So symbol is first. T.symbol equals that. Okay, what's after that? The associativity. No, you've got to put T first. Oh gosh. Okay, where are we? Assoc equals assoc.left. Okay, so the plus operator has a left associativity. An example of an operator that has a right associativity would be the power operator. Yeah, but we're not doing that at the moment. We might add it at the end, I don't know. Alright, what's the next value? Okay, we've got associativity, precedence, and parameter count. Okay, so t.precedence equals, I might say 10. Okay, so this is quite interesting, but it's actually up to the programmer, the precedence. And famously, quite famously, the designers of C++, that's Bjarne Stroustrup and his friends, and Kernighan and Ritchie, who designed the C language, yeah, they changed the precedence from the standard mathematical model. But look, the precedence to each expression parser will be different. It's completely up to the programmer. I'm going to set the precedence of the plus symbol to 10. That's just something I've decided. And that way, because it's 10, we can add operators with a lower precedence. You know, we could use 5 for the precedence, and we can obviously add operators with a higher precedence. So something like the multiplication, which we're about to go through, that operator has a higher precedence than 10. You could also, if you want, use a floating point value for precedence. That way you can add sort of, you know, lots and lots of precedences less than or greater than a particular operator. So this way here I'm doing it is, you know, it's a little inflexible, and the precedence just here being set to 10 would mean that we can only have 10 different precedences below this, but I mean it's not going to make much difference since we've only got 4 operators. Okay, that's what do I oh, parameter count. Yeah, okay, so t.parameter count equals 2. Break. Alrighty, so you might actually want to split that and not have it all in one line, like a, where are we? Oh. Yeah, but that's a full description just there of the plus operator. So now we've just got to do the same thing for the other 4 operators. If I just copy and paste that 4 times, that, and we might also make a default case. And I'll say with the default case that the token type equals token type dot nothing. No, dot nothing I said. And break. Alrighty, so if it's not a number, if it's not a bracket, and if it falls through all of these operators, then we don't know what it is. We'll just set the token type to nothing and return that. Okay, so at the end of the method we're going to return t, the token that we're building. Okay, back to defining our operators. So the second operator we'll define is the minus symbol, and in this particular method, the token, what was it, string to token method, we don't know if this is the unary negative symbol or the binary minus symbol. We don't know how many parameters it takes, so we'll just assume that it's the minus symbol and it takes 2 parameters. Yeah, just like that. The reason that we don't know is because it's actually defined by what's happened before this operator in the expression. So if there's a number just before this operator, then it means the minus symbol. If there's not a number, then it could well be the negative symbol. Anyway, we'll look at how you differentiate that in a later tute. Okay, so the next token, or the next operator, might be the multiplication operator, and that has a symbol like that. It's got a higher precedence than negative and positive, so it doesn't really matter what you set it to, but I'm going to set it to 20. That's higher than negative and positive. And it also takes 2 parameters. And the final operator that we're going to define is division. That has a symbol like that, and it takes 2, but it's also got a higher precedence. Okay, so there's our 4 operators, and you'll note that it'd be really, really easy to just add another operator anytime you like, so we could do something like the power operator, which is a little hat, just like that. And like that. And we might give it a higher precedence than multiplication and division. Maybe 40. And it's right associative. So something like that might be the power operator. And it's up to you, really. The other thing to be careful of is that the unary negative operator, the operator that takes 1 parameter, first of all we'll change that to 1. But it's also really common to use a very high precedence so that, you know, those unary operators get done first. And positive can be used in the same way as a unary operator. Yeah, they have a very high precedence, even higher than multiplication and division. Anyway, that's our basic token class just there. It doesn't do a great deal at the moment, but we're all set up to read a string expression from our calculator in the next tute and start splitting it into separate tokens. And from there we can pass it through a shunting out algorithm, and then once it's in reverse Polish we can evaluate the expression. Good stuff. Alright, well thank you very much for listening, and see you later.